A function defined by two or more equations over a specified domain is called a piecewise defined function. So we're going to look at a more in-depth kind of function. So first off, what is a function? I forgot. It's been a long day.
Input and output.
It has an input and output. I agree. It is a kind of relation. What makes it a special kind of relation, dealing with an input and output?
Every input has only one output.
Yes. Every input maps to exactly one output. Every element in the domain maps to one element in the range. Y'all all remembered that, right? Yeah. I mean, I stressed that enough, yeah. And I'm going to ask you probably every day until
Watch the video again. I don't know.
until about November. I might ask you every day what a function is because, hey, you need to remember. So let's look again at what this is talking about, piecewise function. Well, when you see this, okay, I see the word piece. So literally this function is going to be in different pieces. Think about like, I don't know, Lego blocks or puzzle pieces, right? You've got to put them together to make the full picture because it's going to be made up into two or more pieces. So again, a function is defined by two or more equations, those are the two or more pieces, over a specified domain. So right here is an example of a piecewise function. So let's look here and talk about what this is saying. So the function evaluated at x is equal to, right? Anytime you see this brace like this, that gives you a hint, hey, I'm looking at a piecewise function. So the function is x squared plus 1, but it's only this when x is less than 0. So what are some examples when I would use this part of the function? Well, only when x is less than 0. So -1, -2, -3, -4. Whenever I'm plugging in something less than 0, I plug it into this piece. Now, the other piece of this function is x minus 1. This is true when x is greater than or equal to 0. So when would I use this piece? Well, when the x I'm plugging in is 0, 1, 2, 3, 4, 5, up to 183, right? Anything that's positive or 0 plugs in here. Anything less than 0 will plug in here. Okay, so let's look at what this question is asking. It's telling me to evaluate the function at 3 specific places. I have to find the function evaluated at -1. I have to find the function evaluated at 0. And I have to have the function evaluated at 1. So those are my 3 x values they're wanting me to plug in for. So let's start with -1. So when I plug in -1, which piece do I plug it into? The top one, right? Because that's for all x's less than 0. So when I plug -1 in there, I get -1 squared plus 1. When I square -1, I get +1, and 1 plus 1 is 2. Questions about that? Let's look at the second one, the blue one. Now my function's evaluated at 0. Okay, well, which piece do I plug into when I'm evaluating at 0? I plug it into the bottom piece, right, the x minus 1. Because I plug in there for anything greater than or equal to 0. So when I plug in 0 for x, I'm going to get 0 minus 1, which evaluates to be -1. And then the last piece, I'm evaluating when my x value is 1. So when x is 1, I'm going to plug into the bottom piece again. So that would be 1 minus 1, which evaluates to be 0. -5. So which function did you plug into?
It
Plug into the top one. Negative 2 squared plus 1 should be 4 plus 1, which is 5. That's correct. Any questions on that one? Pick a number 1 through 5. It's 3. Pick a number 1 through 2. Y'all do know y'all don't pick, right? You know that like my phone picks. It is 2. Okay. Which function do you plug into, or which piece, the top one or the bottom one? Bottom. I agree. And what'd you get when you plugged in? Very good. 2 minus 1, which is 1. Any questions there? Pick a number 1 through 5. It's 3. All right, Huber. Which function did you, or which piece of the function did you plug into? The bottom one. Yes, that's correct. And what'd you get? 2. Look at the most prevalent piecewise function. It is called the absolute value function. Did you guys graph absolute value functions last year? Yes, no, maybe. So you know that the shape of an absolute value function is a V? Yep. And the way that we can actually define it, the graph of f of x equals the absolute value of x, is a piecewise function. So think about it. What happens if we choose an x that is 0 or is positive? Then what do we do with an absolute value function? We keep it the same. Right? When we take the absolute value of something, we want it to be the positive of that number. So if I pick 4, the absolute value of 4 is 4. If I pick 8, the absolute value of 8 is 8. So anytime you pick something positive or 0, then whatever you pick the x to be is what our x is going to be. However, if you pick something that is negative to plug in here, the absolute value of negative 2, we know that we change the sign and make it positive 2. So when we define that, think about it. If I pick a negative x, then I'm going to change the sign of that x minus the negative number. So this is our piecewise function for the absolute value. All right, so let's look at all these characteristics of it here. So the domain, what did the domain represent? It's all possible x values. So look at the graph left to right for the x's. So what all x's does this take on? Well, it's got arrows, even though we don't see them. It goes forever in both directions, left and right. So the domain is all real numbers, negative infinity to positive infinity. Next, we're going to look at the range. So the range is the list of possible y values. Okay, well, we got something fishy going on. The range is happening, or their graph is happening up here, but then when I get to 0, the graph doesn't go beneath that. So the lowest y value in the range is 0, but then it continues all the way up to positive infinity. So we say the range is from 0 to infinity, and the 0 is included with a bracket. That lets me know that it actually happens at 0. All right, next, the x or y intercepts. Well, there's only one of them, and it is the origin. It doesn't cross the x-axis anywhere else or the y-axis anywhere else. All right, now look here. The last time we looked at the line was increasing everywhere. This one is not increasing everywhere. If I read the graph from left to right, what's happening? Well, as I approach the graph, the line is going down. Therefore, it is decreasing from negative infinity all the way up until 0. And at 0, it stops decreasing. And then as I keep going, the line starts going back up. So my graph increases forever in that direction. So that's what we're saying here. The graph decreases from negative infinity to 0. It increases from 0 to infinity. So these are the x values for where the graph is decreasing or increasing. Of a function can be described explicitly or it can be implied by the expression used to define the function. The implied domain is a set of all real numbers for which the expression is defined. Okay, so let's think about here very quickly. By default, all of our functions that are listed in function notation, like this, we should be able to plug in any x value we want and get a y value. All right, what are some rules in math that we are not allowed to break, though? There's a couple of things that if we do them, we break math.
Divide by 0.
Divide by 0. If I divide by 0, it can't happen. So we know we can never divide by 0. That's rule number 1. Now there's one more rule similar to that we can do that will break math.
Have a negative under a radical.
More specifically, underneath a square root. We can't take the square root of a negative. Right? Because radicals could be cube roots. That's still a radical. And you can take a negative of a cube root. But yes, you can't have a negative underneath a square root. I'm taking the second root from the radical.
I mean, you could, but you have imaginary numbers.
Yeah, sure.
Sure.
Okay? So, right here, the function f of x equals x squared minus 4 has an implied domain that consists of all real numbers other than positive or negative 2. These two values are not included, or they are excluded from the domain, because you cannot divide by 0. Another common type of implied domain that is used to avoid even roots of negative numbers. For example, the function square root of x is defined for only x values that are greater than or equal to 0. So its implied domain is the interval from 0 to infinity. In general, the domain of a function excludes values that cause division by 0 or result in the even root of a negative number. So again, when they're talking about even root, it's what we talked about before. We can't take a square root or a 4th root, 6th root, 8th root. That's what they mean by even root. But you can take a cube root of a negative. Because I can multiply 3 things together to get a negative. But I can't multiply 2 or 4 or 6 and get something that's negative. Okay, so right here, example 5. It asks me to find the domain of each function. Okay, so A part. This time, my function is just a list of ordered pairs. So when I have a list of ordered pairs, the domain is all x values that are used. So we would say here the domain of A is going to be -3, -1, 0, 2, and 4. Now whenever we list out the domain like this, we want to put it in order from least to greatest every time. So when you have a list of x's and you're going to put them, or you're going to list them as the domain, put them in order from least to greatest. Have you seen this notation before? Domain notation. So you, capital D, colon, and then you put an open brace, list your elements in a closed brace. Maybe not. Okay, B part. Now then I have something in function notation. I have an equation. G of x equals -3x squared plus 4x plus 5. So I know I can typically plug in anything for x. I'm only looking for 2 possible errors. Is there a way that I could divide by 0 in B? No, there's no fraction. Is there a way I could take a square root of a negative in B? No, there's no square root. So because there's no fraction and there's no square root, my domain can be any x possible. So I would say here the domain is all real numbers. So the way we say that is we can say domain is from -infinity to positive infinity, putting it in domain or in interval notation. So again, I don't really like interval notation because what does that look like? It looks like an ordered pair, right? So the reason I do it in interval notation is because if you take math classes at Northeast and you use the My Math Lab, they require you to put it in as interval notation. So I'm just going to say it here. This is not an ordered pair. Right? Not an ordered pair. Even though it's the same, it looks very similar. And that's why I don't like it. But this tells me the lowest x value is -infinity and the highest x value is positive infinity. And includes everything between there. Okay? Last one here is C part. So again, I have a function that is listed as an equation. So I'm going to assume that it's all real numbers. However, I got to look for these two possibilities. Could I divide by 0 here? Yes, I could, because I have a fraction. So how can I make sure that I don't divide by 0? Well, I'm going to find all values that make the denominator be 0. If x plus 5 becomes 0, it breaks, because then I have 1 over 0. Does everybody understand? So x plus 5 cannot be 0, so let's find out what makes that 0. So we would set the equation equal to 0 and solve. So if x plus 5 equals 0, I subtract 5 from both sides. So again, this one's pretty simple. You could have done this without solving, right? But x being negative 5 gives me an error. That is a big problem. So when I list my domain, I want to include everything except for negative 5. So the way we do that, we'll say the domain is, so the lowest possible value is still negative infinity, and we can plug in anything all the way up until negative 5. And at negative 5, I get a problem, right? Negative 5 is no good. So to make sure that I'm telling you you can't pick negative 5, I use the parentheses. Right? Have y'all seen that before? Parentheses versus brace. Okay, so we'll look at an example in a second where we use a brace versus a parenthesis. If you see a parenthesis on a number, that means that you can't use that number. You can use everything up until that number, but not that number. Okay? So infinities always have parentheses because infinities aren't numbers. So you can't pick a number because that's not a number. It's a concept. Right? It means it's forever away in this direction. So infinities always have parentheses. Numbers can have parentheses or brackets. Okay, so I could do anything from negative infinity up to negative 5, can include negative 5, and then I want to start again. So the way that we say, I've got more to tell you, we use what's called a union, which is like a capital U without the little bar at the end, right? This tells me that from negative infinity to negative 5, and then what else is in my domain? Well, everything greater than negative 5 till positive infinity is also in my domain. So this says the domain is everything from negative infinity to negative 5 and from negative 5 to infinity. But you notice we don't include negative 5 in either one of these because there's no brace around it. So we're skipping negative 5 in my domain. Okay, so if I had to find the domain of a function that is the square root of 3x plus 1. Okay? So again, the domain defaults to all real numbers. Except I can't have either one of these. Could I possibly divide by 0 here? No, there's no fraction. Could I take the square root of a negative? Yes, I could, because I have a square root. So what has to be true? Well, in order to make sure I don't take the square root of a negative, what's underneath the square root has to be greater than or equal to 0. If it's negative, it gives me a problem. So we just say what's underneath the square root has to be bigger than or equal to 0. We set up our own inequality. That ensures me whatever's underneath there is not going to be negative. It has to be 0 or bigger. Now when we solve it, okay, we subtract 1. That tells me 3x is bigger than or equal to negative 1. Divide by 3. That tells me x is bigger than or equal to negative 1/3. So as long as I pick something bigger than or equal to, oh gosh, what have I done? As long as I pick something bigger than or equal to negative 1/3, then my function won't break. I won't take the square root of a negative. So here is how we say that. Now, will negative 1/3 work? Can I plug it in and make it work? Well, let's see. If I plug in negative 1/3, 3 times negative 1/3 is negative 1. Negative 1 plus 1 is 0. Can I take the square root of 0? Yes. What number times itself is 0? 0. So it works. So negative 1/3 is included in my domain. I can plug it in. But I can't plug in anything less than negative 1/3. Does that make sense? It has to be bigger than or equal to negative 1/3. So when I list the domain there, the smallest possible value is negative 1/3. But to show that that's included, we put a brace instead of a parenthesis. That means negative 1/3 counts. We're not starting right after it. We're starting at that number. And then it can be anything bigger than it, so it goes all the way till positive infinity. And that would be a parenthesis. For a part, what is the domain? Absolutely. Any questions on a part? So when you have a list of ordered pairs, just pick all the x's. Put them in order from least to greatest. Pick a number 1 through 5. Pick a number 1 through 5. Pick a number 1 through 5. It keeps picking 3. It's 1. Pick a number 1 through 3. It's 1. B part, the domain.
I didn't really do that one yet.
Okay. So I've got a function. So what's the domain default to with a function? All real numbers. I assume it's all real numbers unless I find one of these two errors. Is there a possibility you could divide by 0? How do you know that? Because it's a fraction, right? You see a fraction, you have a variable in the bottom, you could divide by 0. So I have to make sure that this, the denominator, does not become 0. If it becomes 0, bad. So I say 3 minus x is 0, and I want to find out where does that happen. So when I solve that, I could add x to both sides to tell me at x equals 3. Right? And again, so this is a simple one. If I plug in 3 here, 3 minus 3 is 0. 0 bad. So I have to make sure my domain cannot have 0 or cannot have 3 in it. So when I list my domain, I can have anything but 3. So it goes from negative infinity up until 3, but we don't include 3. And it goes on from 3 up until positive infinity.
Why would you not use the bracket thing?
For 3?
Well, not on the side of 3, but on the side of infinity, so since you
Okay? Because you never get a bracket on infinity. Because infinity can't be fenced in. You can't say you can go all the way up to infinity and then you can stop here. Because wherever you think the end is, I can tell you another number after the end. Right? You can't fence in all the numbers. It's impossible. So on the ends, we can't ever include them. Okay, so I've got these two. It tells me to find the domain of each function. So first I have to find the domain of the volume of a sphere. And then B part, find the domain of that radical. Thanks. Okay, so if I'm finding the volume of a sphere, can this number be negative?
No.
Can you have a negative volume? No. Volume cannot be any less than 0. So that means that this number here cannot be less than 0. It has to be bigger than or equal to 0. So if I solve, I'm going to divide by 4/3 pi. Divide by 4/3 pi. Well, guess what that's going to give me? R cubed is greater than or equal to 0. And now I got to take a cube root. Well, guess what number times itself 3 times is 0? 0. So the cube root of 0 is 0. So when I get r by itself, it tells me the radius has to be positive. That's not groundbreaking. You knew that too. Distances have to be at least 0. You can't have a distance that's negative. unless you're in physics and you're talking about direction, but we're not doing that yet. So, because the radius has to be bigger than or equal to 0, then the domain would be all things bigger than or equal to 0. So we would say the domain, the lowest possible value it can take is 0. It could be 0, because you could have nothing, but it can't be less than 0. So we include 0 with a bracket, and it could go up to infinity, which you're going to put a parenthesis around. Do y'all know why I put a parenthesis around infinity? You can't contain it. It's so big. You can't fence that in. Okay. B part. I've got a radical, a square root. So what's underneath it cannot be negative. What's underneath it must be bigger than or equal to 0. So I'm going to say what's underneath that radical must be bigger than or equal to 0. Because that's what it has to be. I solve. So I'm going to move the 3x over. That's going to give me 4 must be greater than or equal to 3x. Divide by 3. That tells me x is less than or equal to 4/3. I'm going to flip that around just because it's a little easier to think about it in that direction. So x is less than or equal to 4/3. So now I can only pick stuff up to 4/3. My x has to be less than or equal to 4/3. So that means the smallest possible value is negative infinity. I can choose things less than 4/3. I just can't pick anything bigger than 4/3. So negative infinity works all the way up until 4/3. But then I can't plug in anything bigger than 4/3 or it breaks. So for A, we know 2 pi r must be greater than or equal to 0. If I divide by 2 pi, that tells me r is greater than or equal to 0. So the domain would be all things from 0 to infinity. 0 is included, infinity is not. B part, there's a possibility I could take the square root of a negative. So what is underneath the radical has to be bigger than or equal to 0. So what's underneath the radical is bigger than or equal to 0. When I solve, I add 16 to both sides. That tells me x must be greater than or equal to 16. So the things that I can plug in must be bigger than or equal to 16. So the smallest value allowed is 16, all the way up until positive infinity.